Bismillahirrahmanirrahim. In this very short video, we'll try to understand the difference between continuous and discrete, or continuous signal and discrete signal, and also the difference between analog signal and digital signal. So, what is continuous signal? A continuous signal is a type of signal which is present at every point in the time interval. So this is the time axis and this is the amplitude axis, and you can see the signal is present at every moment in time. This is the time, and that is why it is continuous. There is no break in between. So this is a continuous signal. On the contrary, when we talk of discrete signal, we should first of all understand the meaning of discrete. So the discrete means separate, different, distinct. So at separate points, if we take the signal, like we are taking the signal at 0 time, so this is the signal. At 1 second, this is the signal. We are just taking a sample here at 1 second. Then at 2 seconds, this is the value of the signal, and 3 seconds, this is the value of the signal. So this is now discrete signal, that the signal at only some distinct points. So this is a discrete signal. Generally, to draw it, we take help of a lines. We also draw lines with this, which is actually not required. This is the discrete signal, but let's follow the convention. So this is the discrete signal. Now next item is analog signal. Now analog signal and continuous signal, there is no difference, same signal, just two different names. So it's exactly the same signal. And now let's see what is digital signal. So we had learned this, the analog signal, and we had learned the discrete signal. Now if we apply a chart over it with the various levels, so like this, level 0, level 1, level 2, level 3, if it this put on the discrete signal, it will look like this. So this is, now you can see the signals at different points. So up to this point, the signal is discrete. Now what we'll do is what is known as quantization or approximation to go into the digital signal. So we approximate the signal value to the nearest level. So this is key. Now look at this point. This signal is about, let's say, 0.4 volt. So what we'll do is approximate it to the nearest. The nearest is 0. So we'll approximate it to 0. Similarly, this signal is slightly less than 1. We'll approximate it to 1 volt. This one is slightly more than 4, but we'll approximate it 4. This one is again in between 4 and 5, let's say 4.5. We'll approximate this also as 4. And similarly, this one will approximate as 4. This is slightly less than 2, we'll approximate it as 2. So the approximated signal, approximated to the levels given, nearest to the levels given, then the signal will be a digital signal. Now this process is actually called quantization. So by quantization, we get the digital signal, and generally we represent it in terms of a binary values. So this, instead of writing 0 volt or 1 volt or 2 volt, we write it 0, 0, 0, 0, 0, 1, 0, 1, 0. So this is the binary representation of the decimal values. It has been represented with 3 bits. Now bit is binary digit. Okay. Now there is some common practice. Digital signals are represented as 8 bits. So that is the lowest level. Here we have represented it with 3 bits. So 2 raised to the power 3, we get 8 levels. From here to here we have 8 levels. If we represent it with 8 bits, that means 0, 0, 0, 0, 0, 0, 0, 0, 8 bits. and similarly final will be 1111, 1111, 8 bits. So we'll get 256 levels. So instead of 8 levels, we'll have 256 levels, and that will bring a more accurate result. But that's not the end. We can have 65,536 levels with 16 bits, 16.8 million levels with 24 bits, and 4.3 billion levels with 32 bits. And all this possible to manipulate with the help of our latest computers. Now, what are the advantages of digital techniques? Digital systems are generally easier to design. Information storage is easy. We have now USB, disk drive, everything. Accuracy and precision are greater. Operation can be programmed, so you can use the computer programming. Digital circuits are less affected by noise. So this is one of the very good advantages, that noise does not affect much. And more digital circuitry can be fabricated on IC chips. So just a small IC chip can hold thousands of the circuitry. And finally, how to take advantage of digital techniques. To take advantage of digital techniques when dealing with analog inputs and outputs, 3 steps must be followed. Most of the real-time signals are analog, like the variation in temperature, audio signals, and all those things. So what we do, we first of all convert the real-world analog signal into digital form. So here is the diagram. If you have an analog signal, variation in temperature, we convert in with the help of our analog to digital converters into digital signals. Then process or operate on the digital information. Now this digital information then processed in the computer, and then after that convert the digital input back to the real world signal. So we convert it back. So if it is a music that we have digitized, then we convert it into analog form so we can hear and we can understand that music. So I hope this gives you a preliminary idea about the various terms, continuous, discrete, analog, digital. Thank you.